Engineers, welcome to my YouTube channel. Today I want to show you real life building, complete G+2 building design in Staadpro, Advanced Content and Autocad. So I have already imported my model here in Autocad. I've opened a new project in Staadpro Advanced Connect. So let us start. I have the architectural plan here. I will copy the typical first and second floor and roof plan, and I will use that one to model my building. So I will just drag this one here, then hit escape in my keyboard. The first thing you import a drawing in AutoCAD is to scale, and from here we can tell that the distance from the edge of that beam. So let's first make sure the units are in millimeters. So DWG in your keyboard, it is 3, so this is already in millimeters. So you can see 3 is millimeters, right? So the units are in millimeters. So we need to find the distance from the edge of this beam to the edge of that beam, the actual distance, so that we can scale. But we know that the distance is 8,000 millimeters from what we can see. So we can determine the distance from the grid to the grid on the other side, and we can tell that the beam is 200 millimeters. So the distance between this grid and the other grid should be 8,200 millimeters, because it is in the center of that beam, which is just 100, then plus 100. So let's find the actual distance so that we can use it to scale. So I need to activate my snap. Okay, so we need to let's snap the intersection, and we're going to use the linear from that point up to this point. Then control enter, then we drag this down. So you can see the current distance is 57.4001 millimeters, because the units are now in millimeters. So to scale this, we need to find the scale. We need to divide the actual distance with this the current distance. So it will be 8,200 if divided by 57.4001. Then is equals, then you can see that the scale is 142.85. so we'll just copy the answer. That is the scale. We just copy the scale, then I'll select the entire the plan, then scale, then paste. So select our base point down here, then just paste the scale, then enter, hit enter in your keyboard. So let's see now the distance. If it is 8,200 millimeters, so the current distance is 8,199.99982. If you round off, you find that the distance is approximately 8,200 millimeters. So we will change the dimension style. So select D, hit D in your keyboard, select dim style, then we can modify our dimension style. So our precision, we need to be 0, just 0. Okay, we will increase the text size so we can multiply this by our scale. So here we also use the scale we find. So if you multiply the scale, that is 142 times 4.5 is approximately 5500. I mean 550. If you multiply 142 times 4.5, also the arrow size multiply by 550, multiply by 142, then just okay, then I will close. Then you can see now that distance is 8200 millimeters. So we have scaled this typical first, second, and roof plan. So in modifying the dim style, it is also important to use the scale which you determined. So we are going to turn off some layers now so that we can do the dimensioning ourselves. So I'm going to turn off some layers. I will turn off my text. So we are going to delete these lines. That is the lines for dimensions from the architecture. So I will pick these and select similar, right? So we are going to just delete. So delete. Now we can do the dimensioning. I just activate the dimension. We are going to dimension grid to grid distance, okay, in the X direction and in the Z direction. So in the Y direction, that is based on the Staadpro. We know the story to story height is 2.85. So I will use the linear. So we need to snap at so I'm going to pick the linear. So it's already snapped at nearest point. So from that grid to this grid, drag it somewhere there, then go to annotate, continue the dimensioning from that grid to this grid, then from that grid to, so we're going to dimension this X direction, because based on Staadpro we are going in the X direction. So I'm going to delete this. You can see the scale was very small. So each time you import a drawing in Autocad, you must scale first, okay? So I'm going to just move this somewhere. Just drag it down here. annotate, then continue. I think we have missed this point, so I'm going to delete select that, pick this the last point, then can continue the dimension. Okay. Now we're going to dimension in the Z direction. I'm going to pick linear from that point. So I think there's an error here, because I think this should be 2900. So let's see, it is snapped at the other point, so you can just drag this some point there to unsnap it. So let's just finish dimensioning in the Z direction, then we will go back to confirm that the dimension is accurate. So it's being snapped at nearest, so this one we have missed the point, because you can see it's not touching the grid point. So I'm going just to delete this one, the last point, then hit continue, then select my last point. So let's go back to this, select this point, then to the first grid in the X direction. So you can see it is now to 900. So to unsub this, I'll just continue that point, then delete, so that we can continue. We can select another point. Now I will select this point up to there. And remember, grid is usually at the center of each wall. So I don't want to dimension the grids. I just want to dimension the grids for the walls on the right hand side. So that's why I will just move the next point, then to this point. Then we can do the grids on the right hand side, the left hand side later. So escape it. Now I want to measure the left hand side, because the walls are not on the same grid, right? So that will make my work easier. Because I can detect, I can clearly tell the symmetry, I will need to modify some of my dimensions. Because if you can look at this plan, you can see there is symmetry. So let's delete, let me delete these grids in this void. there is symmetry. If you draw as a midpoint here, you can see that there is two sides which are similar. So for this structure type, an experienced engineer would normally model halfway and design it halfway, and then mirror the design you find to the other half. That will enable you to work faster, and you will be more accurate because you'll have a smaller you'll be having a smaller structure to deal with, so you'll be more accurate and you will work faster. So that's why I can just modify my dimension to force that symmetry, all right? Because I also want to not to interfere with uh, the distance, the plan of the architecture, because you don't know the area or the plot which this structure is going to be constructed can be limited in size. So I can just modify these grid to grid distances, but make sure at the end of the day the total length is just adding up to be the same. So that's why I will make this side 30-50. I will reduce some portion and add to the other portions which I want to be similar. So this one I will reduce by 50 and add that 50 somewhere down here, because I want to make sure I have that symmetry. So let me copy this. So it is good to work as a team with the architecture and other stakeholders to make sure that you don't contradict each other. So I want to change my dim style. We'll add new style, Airy bold, Airy and then bold, then apply and close. Then I will increase the text height. So select properties, select Airy bold, then I will drag it there. So you should work as a team, because contradiction can be costly. So I will try as much to get that symmetry, so that when I work, I'll be sure I'm within the limited the provided area. So this length should be similar to the one up there, but you can see I have not increased or reduced because I have just subtracted 50 from this, that 100, and added to the other one at the top. So at the end of the day, the total is just same, maybe just a very small difference. So that is what I'm basically trying to do here. Before I start modeling this half model in Staadpro. So I'll match this property, that one. So this one should also be similar to there. So here is also that 50. So I am confirming they are similar. They are similar about the mirror point or about the mirror line. Okay. So I want to show you the two similar sides about the mirror line. So I will use the polyline. I will use the polyline just to drag and show you the two similar shapes about the mirror line in this plan. So I'm dragging that point to that point, that point, to that point, that point. I'm just trying to illustrate because this can be confusing. That's why. So let me select the polyline I've just created, and then I will. Okay. So you can see this shape. There's another similar shape like that about the mirror line. So So I just need to design one of those. I will design one, and then the other portion but in the case it was a rectangle, you can just do half, or you can divide it into 4 equal parts. So you can see that shape there, and if so I can just delete one of these, design one of model one, and then I will mirror the design, or just copy the design to the other half. So I will just delete. So I hope you have understood what I'm trying to explain here. So I can just draw a horizontal line, so XLH, then I can trim the top part, right? Select the line, then trim. So you can just delete, because the layers are different, they cannot be trimmed, so we can just maybe delete or drag them. So in case you have a similar shape to this, you can just easily understand or what you just did. So remember, some walls on the right hand side are not on the same grid, so that's why I'm going to dimension the left hand side separately, because the walls are not on the same grid. So from that point to this point, and I know that the distance is 5600, because this is a project we have already accomplished. So we need to do the dimension, make sure the height is 5600. then continue, go to annotate, continue. So we continue from that point. So I need this beam to be on the same grid. From the structural point of view, the beam should be on the same grid with the other one, because they are very close to each other. So there is no point of adding a different grid. So sometimes you don't have to do exactly from the architecture, but you should be just work as a team to make sure there are no contradiction. Sometimes the architecture also just do things to finish their work faster. So trying to see if I can join these lines. So you can see this one is not so I want to add the grids. I want to add my own grids, so I'll do the XLV to the grids in the running the Z direction. Because you can see the beam is not in the correct place, because as I have said, this is a project that we have already done, so I want to do it exactly the way we did it. So I do in the grids running in the X direction from that point. So that one is not, make sure that select the nearest so that the grids will be in the exact point with the original grid, because I was not able to change the properties of these. Escape. So I'm going to delete this grid at this point, because there was one which was not in the exact position. So I'm going to move this grid to that point. We are going to delete this. Continue, then just drag it there to unsnap it. Drag and delete to unsnap it because it is snapped in the last point we dimensioned. So continue, select the new point to that point. So I think this should not be how it's supposed to be, because so I think this beam was not supposed to be there. As I have told you, this is a project we have already done, so I'm trying my best to just model it the way we did it. So I will move the position of this beam to the next grid, because I think that is the position this beam is supposed to be. That's why that's where comes RFM, that is request for more information. That's why you should always work as a team, because contradiction can be costly, not only in time but also in other ways. So I will just move this grid line to that point nearest. Okay, so I think this one is now okay. Then I will trim. I want to trim this grid, so I'll draw a triangle. Then select it and then trim. So unfortunately most of this video we have taken most of our time in designing it in Autocad, because I wanted the principle of modeling halfway to sink into my viewers, so please bear with me. So that's why you can see I had to fix some distances for as long as the total distance will not be altered, it will be just the same. Because if maybe I increase the size of the building, and you know probably there will be no enough space, so that is why I was adding and subtracting to make sure that the total size of the building is just the same, but I have that symmetry. So I'm going to name my grid So this is based on the coordinates of grids in Staadpro. Okay, so I'm going to make sure that so my 0 point, that is the x and z 0 is at the intersection between this grid at that point. So this is x and z. So x is the distance going that way, and z is the distance going that way. All right. So I hope you understand why I'm adding that 0. So that is the coordinate in Staadpro. So I'll move it to that position. Then I will copy. So remember, if I'm going this direction, only my z will be changing, but my x will remain as 0. That is in Staadpro, based on Staadpro coordinates. So at that point, it will be the summation of 3050 plus 3000 plus 3050. So that is the increase in z, plus 3000 plus 3050. So is equals 9100. So the coordinate at this point will be 0 and then 9100. The coordinate at this point will be 9100 plus 45 2405, right? So it's equals to this one is equals to 11505. The other one is 0 plus 11 plus 5600. $17,105. So I'll add the opening and closing to indicate that these one are coordinates, because I'm going to model using the coordinates in Staadpro. So now we will add the coordinates in the right hand side, because now the walls on that side are not at the same grid with the walls in the right hand side. So I'll finish adding my opening and closing. So when I move to the right hand side, now Z will be 0, but X will change. So I will, Z now will be the summation of that distance. So I will add the grids at the midpoint of these walls. So X will be the summation of all that. So 2900 plus 4200 plus 4000 plus 4210 5600. To 900, let's repeat it, plus 4200 plus 4000 plus 4210 plus 3990 plus 1700 plus 5600. So 2660. Copy. Then I'm going to change now the X be 2660. 26600. So paste. Then I will just copy these, but now I will change the Z coordinate. Drag it to that point. That point, and finally that point. So this one might confuse me, so let us delete it because we altered. I'll just change it 50, right? And then also change this one to 3050. So let's just delete these ones. We are done with them. So we are going to now just change the Z coordinate. That will be 3050. Now the coordinate, remember, is the summation. Now this one will be 6050. 9100, right? $60.50 plus that 50 is 9100, right? plus again 3050 total of 150, right? So let's activate our calculator again. Is equals total of 150, then again plus 3000 is equals to 15150 again plus 3050 should be equals to 18200. So there is somewhere we did a mistake, because you can see the coordinates are not adding to 18200 on the right hand side, but we know the coordinates should be same. So there's somewhere we did an error on this on the other side, so you should be very careful. So this one is 18200, right? So I can just drag this because clearly we see that there's an error there. So let me drag this to that point. That is 18200. The only thing will change now will be x is equals to 0. So we will subtract 18200 minus 5600. Just drag it. So let's change this one to 0. The x axis 0 again. Now the z axis will be 18200 minus 5600 is equals total of 600. Total of 600. Then let's copy and then subtract 1700 So we just type copy and then select the command, then drag it out there. We just change the Z axis. When 1700 be equals to, that point will be 10900, right? Again minus 2004, 2405, right? So that will be equals to 8495. So when we go to the 95, so the first point is still 00, right? And remember, this wall is also not on the same grid with the other wall, so no problem. Now we just copy in the X direction. Now the X axis will be the one changing. So copy that point, again to that point, just let's put some down here, that point. You can just alternate so that not be overcrowding. So I will just subtract in the, I will just add in the X direction to 900. So right, so the only thing that's now changing is now the X axis. Now this only will be to 900. The other one will be, remember it is the summation of the 900 plus 4200. Let's activate the calculator again. Select calculator, type C and select calculator. Now 2900 plus 4200. Now that will be equals to 7100. So the axis here is 7100, comma 18200. That is X and Z. Plus 400, that will be around 11100. 11100 plus 4210 15310, that point, all right, plus 3990 that 990 be equals to 19300, right, plus 1700 again will be equals to 21,000, right? So a lot of work will be just adding this coordinate, but after we put this coordinate in Excel and copy paste it in Staadpro, we will just model very fast. So I just copy these ones because the top portion is also similar. I will just change in the Z direction, right? So copy, drag it to that point. Then I'll just change Z. Now the Z is 2600. So this one did not change. This one was 2100. 21,000 I mean. Again here was 21,000. Again. So again, this one is in the same grid with the one on top, so that will be 150. This one, now all of them will be at 12,600. So let's just drag them to the correct position, move them the top there to avoid any confusion. Let's change these ones, move. Then again I'll move this one down here. So that one is okay, that position. Then move them up to there. Then now we need to change the Z coordinate to from 18,200 to 12,600. And I'll just copy and then go pasting. Paste. So we also need to add the top coordinate for this balcony. We have a balcony there, so let's drag these, all of them again. And we'll copy and then drag it to that point. Then we'll only change now the Z from 12,600 to 10,600, 10,900. Okay. Then I can just copy and then paste. Then paste. So because this place is congested, I just drag this one away. So we also need the grid for top of our staircase. I can just find the distance. So I will snap at 90 degrees, distance from that nearest to that point. So I need this point for my landing. My first landing. My landing. Okay. So that is 41, 38. So this, if you're not sure, just request for more information. That is 5800, right? So this one I can just, instead of that confusion, just use 4100. So I won't find the coordinate of my staircase. So I just select similar, because these ones are too big, go to property. I'll just reduce the height, text height to 400. Okay, so because they are too congested, then I will drag this away, because I will move those away to that point. Oops, okay, just move them that point, then you don't move it to that point. Then I'll copy, move, and then change the X coordinate only, the first landing, and then to so I will uncheck snap because it's not going exactly where I want being snapped. So then move, so now the X, we change the X now to 4100. This will be 4100. The other side will be now 5800, now in the coordinates, X coordinate. Now so we just copy, drag to the top side, then I just change the Z coordinates to 8495. So edit 8495 and paste it here. So I also need to copy this, then I will just change the x coordinate, because you can see there are still missing coordinates. Move it to that point, then move to that point, then just subtract 5600 here. So this one will be 21,000. Okay, so just copy that, paste, again paste, escape, again paste, again paste this top part, 19300 again. So you can just copy from this, paste, again paste, and then finally paste here. So I'm now completed adding my grids. They are missing grids, so I will let me just add a few more grids. So I'll copy this to that point, then I'll just change the x. So this is going to be down 21,000 I mean. So the next step will be to input our coordinates in Excel, just in the same way, in the same manner they usually put, following this x, y, z, in the same manner they are in Staadpro. So we just open Excel, add x, y, z, and remember y is there, our y will just be 0. Right, so let's open a new Excel workbook. So x, y, z. Node, so start with node. So we just assume that the next number is the one which is 1. All right, z, x, y, z. I will drag, So we are almost starting to model our building in Staadpro. So let me minimize. I want to minimize this Autocad. Then we can just input our coordinate values in our Excel. So here you can start with any, it does not matter. So 26, we start with 2600, and then y is 0, but you can see clearly we made a mistake. This one should be 19,300. All right, so I can just change this one, edit. This one should be 19,300. I forgot to change when we copied. So we can just save, because you can see we have already done a lot of work. If crashes, I'll be in trouble. So just save. So I'll start with 19,300. Y is 0, Z will be 0 again. So my y is 0, so I can just drag this. $21,000, 0, 26,600, 0, then 0. So we are going to go to the next row. So you can just start wherever you feel comfortable. We can either start with the X, so just your choice. 19,300, and then 3050. $21,000, 3050. 26,600. Then 3050. Drag it because it's similar. 19 now, 300. 21,000. So I don't need that negative sign there. $60.50. 26,600, so then we drag, right? $19,300 again. Okay, the next one is, the next grid is starting 0, then 84.95, 4,100 again, and then 5,800, again 84.95, then 5,800. So we will just drag. Okay, so the next one is 19,300, 300. Then the next, then 9,100, again 21,000, then 26,600, then just drag it on the same grid in the Z direction. So the next grid is 0, then 10,900, 4,100, again 5,800, and then then 71,100, then 11,100. So it does not matter the order. Then 15,310, 1,900, 300, 19,300. Okay, so we have reached up to that point. 5, 6, 7, 8. Okay. 5, 6, 7, 8. Okay. Just drag it. So the next one will be 21,000 for this wall. 21,000. And then 12,150. And again 26,600. 12,150. Just drag again. So the next one is this grid 0, that is 12,600. 2,900, 7,100, and then 11,100, then 15,310, followed by 19,300, there is also 21,000, 3, 1, 2, 3, 4, 5, 6, 7. Yeah, there's okay. So drag this to that point. So the next grid will be this one. We are missing So we can just drag this, move to that point, then just change this to 21 and this x. So x coordinate minus 5600, that is 21,000. So 21,000, 15,150. $26,600 and then 15,150. Just drag. So we are now in the last coordinate in the z direction. So we start with 0, 2,900, then 92, 18,200. This is the last point in the z direction. Then 2,900. $15,300 and then 19,300. Yeah, 15. It is 15,000 is 310. Okay. So just change there. So again here 310. Okay. $21. No. Okay. 19,000. Yeah, we are missing something. Then 26,600. So just confirm because making errors. So I will delete the last row. So I will save this file book2, then I will just copy. So if you check, my x, y, and z are in my units are in meter. So I will change the units. So I will change the units here also into meters. So I will divide everything by 1,000. And just copy paste. Two, 3, up to 42, then this one will be equals to this row by 1,000. Then just drag it. Finally, this one should be equals to z that minus this minus 1000, again drag to the last point so that we can now copy the table, copy everything. And paste. So paste. Okay. So let's see the distance, node to node distance, or can go to view, the plan view. So let's add our beams. So you can just drag up to the end. We're going to deal with that later. We are going to split at those points later, so just from that point to the end. So you just select node cursor, hold control, select again, then split geometry. So break the beams at the selected node. So 14 new beams created. So you can see now my beams have been separated. So we are going to again to beam cursor, then just so I'll drag it to that point. So select the nodes and then break the beam at those nodes again. So I want to select all the nodes with columns. You can see where we have our columns, these points, these points, these points, and that point. So all those nodes I will select, then I will do transition repeat, and then I will link points so that we can have our columns, right? So I want columns in all those positions, and all those columns, right? Then we have columns here at our balcony. There are also columns at those positions. There is no column there, then there's a column here. So our staircase, there must be a column. So there is also a column here, although I did not include it. Right, so see the distance. So you should try as much as possible to have column to column distance to be just not more than 6 meters. So I will select all the nodes with columns. I'll go to select node cursor. I select all my nodes with columns. With a column. So I'll do transition repeat in the y direction. I don't have a column there, so just transition repeat in the y direction. My floor to floor height is 2.85 meters. So I will start with foundation. I'll go by negative 1.2, link steps, and okay. Then transition repeat again, then floor to floor height 2.85, then link steps again. Then I will then link steps. So number of steps is 4. Because it is now G plus 3. Then let's see the 3D view. So you select all our beams parallel to X and parallel to Z. Then transition repeat in the Y direction, 2.85, number of steps 4. No link step, then okay. Then we delete because we don't have plinth beam, we don't have the ground beams. So just click X. Just delete. So let's select the beam cursor, then delete. So we missed some beams, so let's first delete these ones. Then I will do transition repeat of the missing beams, because the balconies we have beams, and I will not go floor by floor adding those beams. It will be a lot of task. Select and then let's transition repeat again. In the y direction 2.85, that is floor to floor height, and 4 times. Link steps. No, don't link steps. Then delete these ones. Let's see the 3D view. Just view, display the whole structure. Okay. Then I want to include my water tank slab. So I do transition repeat 2.85, because I have an extra flow for water tank. Then I will link steps. Okay. Then you can go to properties. So we have circular columns in our balcony, and the rest we have rectangular columns. So we'll add sections for our columns. So we define columns. So then add. So let's go to plan view so that we can add the properties for a circular column. So we select that portion, view selected objects only. Then let's view the 3D. Let's select the vertical y direction. Then assign. Yes. So we're going to define so we need rectangular, so 0.25, that is size of column type 1. Add. then view select object, then view the 3D, select the vertical parallel to the Y, beams parallel to Y. Remember in Staadpro all members are beams. So let's view the rendered view to see if they are oriented in the right direction. So the longer side is this, so this one is okay. I mean the H and the H side is the longer side, which is 0.35. okay, 35 again, 0.35 by 0.25. Then I select the beams, view selected objects only, view the 3D, deselect, then select parallel to Y, beams parallel to Y, then assign. So you can confirm by checking the rendered view. You can see the H and the Y, the H and the B, because the H is the longer side of the X section, cross section. So view the whole structure. So we select our water tank. So water tank columns are different type of columns. So column type 3. So water tank should be a bit bigger in size, because they not only carry the water tank but also the staircase. So 0.4, 0.2, 0.225, then add. Then close. So we will define our beams 0.45, then add, let's select all our beams parallel to X and parallel to Z, and assign. So view the selected objects only. So let's view the rendered view. So you can see there is an error because the height of the beam is shorter than the width. So it's vice versa. So you can edit or just add new property. So edit. So the YD is the H, this is the H, so it should be 0.45 by 0.2. Change, close. So let's view the rendered view now. Now this is okay now, right? So we should be able to use the rendered view to confirm. So now you can see the whole structure. We have been able to model the whole structure. and close. Then go back to geometry and select the ground floor beam, selected objects only. Add plates. So these the plates are our slabs, all right? So then save the project. So let's uncheck and view the rendered view. Now you can see we have our plates. So I select all the plates and do transition repeat. Then pick the plate cursor, select, go transition repeat. Then Y direction, float flow height is 2.85, 3 times. 1, 2, 3. So 3 times. And okay. So we'll add our water tank slab. Then we'll save. Then go to view, rendered view. You can see now our rendered view. So we go to properties, add thickness. Add thickness. Our slab height is 150. Then add. Then you can either assign to view or just select all of them. Yes. Then go to utilities, missing properties. So no edit missing properties, just confirming. Then go to materials, all materials concrete, specifications. So I need to add the specification. You can add the master slave node. So these are my coordinates for my COG, which I have already added another video explaining how to find the COG of a structure in Staadpro. So if I hold Shift N in my keyboard, you can now see the nodes. Then I can rotate. So my CO is about here. So just pick the nearest node, because you cannot use orphan node as your COG. So just pick the nearest. So we'll pick 107, 145, 176, 183, and then 1, 2, 3, 4. Yeah. So I'll go to node, add master slave node. So it's legit in its own plane, that is ZX plane, add. So shift L, you can see now, we can see the master slave node. So I'll select all the nodes and assign. I'll pick the node cursor, assign, select all nodes in that flow. Then go to specification and master slave, then assign to the selected nodes. Then if I show it 3D, so if you hold shift L in your keyboard, you can just see. So we'll add another master slave node. The next node was 176. The Z in its own plane. So you can see we pick the node which is nearest to the COG, because the COG is an orphan node. So you don't need to use an orphan node because there will be other errors. So we go to second floor again, because that was that floor. So let's go to view. So just rotate. So the next was 138. So let's first assign this to that flow. Assign. Then we go to specification, add node, add master slave, 138. Master slave 138, and rigid in its own plane. Then I select node cursor, select all nodes in that flow, assign, yes. Then we'll go to the last, the roof flow. Now it was 214, right? So its own plane again, add, select node cursor, select all the nodes, assign to the selected nodes. Make sure it is rigid in its own plane, that is ZX. So we need in the water tank, we also need to use the node which is nearest to the COG, that is 252. So add another master slave node, that is 252. The last node, rigid in its own plane. then add. Then select that view, then node, then assign to the selected nodes. So we have added the master slave, nodes. Then hold Shift L to view for those the view for the master slave node to hide. Okay, so we'll create fixed support, add, then select the support, then go to view, that view, then select all the supports, assign fixed support. Okay, then you go to loading. We will define first wind load, and then select wind definition, add, then close, then type, add. We can just calculate as per SCSC. So we'll go to exposure B, building structure, category 4, and then main building, then just apply. The story height is about 14.25, so change everything to meters. (14.25) enclosed building, apply, then just apply, then okay. Exposure factor 1, then add, then assign to view. Okay, so let's go to view. So all the nodes have been assigned to that exposure, so they have been selected. So the other thing, so we go to CSMIC and add. I'll use Indian generate. Change zone, then go to zone 4, zone 5. Yeah, zone 2. Okay. Then generate, then self weight, then add, self weight, add. So there is no need for changing the sign there because it is automatic. Then go to utilities, member weight, so my wall width is 200 millimeter, that is 0.2 meters. My wall height is 2.85 minus the beam height, that is 0.45, define 2.4, multiplied by, so unit of masonry, which is 9.6. So the so our parapet is it's 4, okay. Then I will add my parapet, add. I'll go now to so I will assign my so I'll select all the beams with wall load. So go to this view, select from first up to second floor, then I select only I just select the walls. So you can see from the architectural plan where I'm having my walls. At this point we don't have a wall there, wall outside, okay. I'll select so you can see where I'm having my walls in this architectural plan. So we are using typical first floor. So we are using typical first, second, and roof floor. Select parallel to X and parallel to Z, then I will assign. So I want to group them. I will call them external wall, then the type is beam, then okay. Then associate. So I'll select all now my parapet walls, which have just a small load of about 4 kilonewtons. just a wall of 1 meter height. So we selected object, view the 3D, select view parallel to X and Y, parallel X and Z. I will group them. So we deselect those ones. So we can just select it because the opening is very small for our entrance, so no problem. So I just name them parapet, type is beam, then OK, then associate. So I'll select the water tank. We also have a parapet wall there. Then I'll select the roof. Select the objects, then let's view the plan view. We need to deselect, then select only the outside portions. Okay, then I select the water tank, then I will go to utility group, create, then name them roof, beams, okay, associate, close. Then let's view the whole structure. Then I'll go to select, then groups, external wall, then assign to the selected. Yes. Select, selected. So the parapet is for the roof and the parapet on also. Then the pressure is for all my my plate. So I'll go to loading, add, dead load. then add, so we should start with seismic load. So never forget that you start with seismic, because it will bring errors in your output. So you should start with seismic, defining seismic EQZ X add EQZ add, then dead load DL add, live load LL add, then wind load Z X add, then wind load Z add, then add, so we'll go to seismic, seismic loads. Now change the direction to Z, then add, dead load add, go to self weight add, should be negative, the sign is paramount. Then we go to we'll go to external wall 9.6, then parapet -4 add, plate load, so finishing, then add, then I go to live load add, plates -4 in the lock Y, okay, and then add, yeah, global Y, so add, so we should make sure the negative is there and the global Y. Then go to wind load add, wind, so there's an error somewhere, add wind, so let's check the error. Wind definition is required in order to assign load, so I'll go to exposure, so the mistake I made was to add my master slave nodes before adding my wind load, so I should delete all the master slave node. And besides, you don't need to add master slave nodes when you have already modeled your plates. You only add master slave node in the scenario you don't want to model your plates. You just use flow load instead. But you can just add our master slave nodes. So add, select, assign, shift L so that you can view. Node, add master slave. Remember we are going to 130 something, 138. Assign to that floor. Then we go to 176. Add and assign to that floor. Then we go to add, and the last one was 214. Then for the roof, assign to that floor, to the roof, all nodes. See if this is going to solve our error, and assign 252. Select node cursor, assign. So you must define the load first before you assign the master slave node. So let's see if this is going to solve our error. Add, calculate. Meters 14.25. Fully enclosed building. Okay. Exposure factor of 1. Add. Calculate. Okay. And add. Then an exposure factor of 1. So assign to view, assign, yes. Let's go now to adding our wind load. Shift L to escape, then add wind load, yeah, X, the X windward. Then on the negative side, on the opposite side, negative. Then we add now wind load Z, add wind load. Now let's change the direction to Z, add positive, add in the negative direction, in the opposite direction, negative, add, close. So you can see now the wind load. So we should, wind load should only act from 10 meters to 14, from 10 meters and higher, right? So we should change from 10 meters and higher, because wind load only applies to high rise. Again, from 10 meters and higher. So low-rise building, wind load does not act in low-rise building 10 meters and high. So you can see now the way our wind load applies. So you can just use shift to see so we'll assign live load, just assign to because only acting on our plates. So self weight assigned to view. Select groups. So this is for our external wall. So let's first assign the plate loads. So remember 9.6 was for external wall, so we'll go to group, external wall, then assign. Then -4 was for our parapet and the roof. Select external, assign yes. So then we save in case we will not lose everything after all that work. So we add load combination BS8110, generate, then add, then close, then go to analysis. So there are two errors. So let's check what is the error. There are two errors. Finish command in load data and above line data is erroneous data. So we need to solve these errors so that we can be able to run our analysis. So there is no multiple structure, there are no offer node, duplicate beams. no duplicate beam. Let's check our loadings. Can just delete my wind load. And then add again. Then add factor of 1. Okay, then add a factor of 1, then add, then assign to view. Wind load X, then wind load X. Then I'll change the name to wind load, change. Wind load from 10 to 15 to 14.25. Add. In the opposite direction, add wind load, change to Z from 10 meters higher, then add the opposite direction, add then go to run analysis, save. I think the same error. So the above line contains erroneous data. So, and then we should check analysis command is out of order or missing in case number. So check data order carefree. So data check mode is entered. So you are forgetting to add analysis, add print, and then close. Then run our analysis again. That was the cause of that error. Sorry for all that. So I suppose our analysis should be able now to complete. We have one warning. So let's view the warning. So UBC has no tension or compression. That is the warning, but there's no error now. So now we can run our concrete design. So define parameters, then we select clear, crack, select, then OK, define parameter. I want a clear cover of, for my beam 25 millimeters, that is 0.025 meters. For column, for that slab for 0.2, that is 20 millimeters. And for my columns 35 millimeters, that is 0.035 meters. My strength of concrete, I will use class 25, that's 25,000, then add. So my grade of steel, I will also add grade that for my column. So for grade of steel, I will use 500 MPa, that is 50,000 kilonewton per meter square. Then I will add design columns, add, then add, take off, add. So for my clear cover, select beams parallel to X and parallel to Z, a cover of 25 millimeters, assigned to selected, yes. For my slab, I will select all my plates. Assign to the selected plates. I select parallel to Y. Assign. That is clear cover for column 35 millimeter. For grade of, I will assign to beams. That is class 25 concrete. Z and X, parallel to Z and X, assigned to the selected beams. For my class 30, I will select all my columns. Also my plates, I will use class 25, so I will assign to selected plates. Then columns parallel to Y, all beams parallel to Y, that is columns, assigned to the selected beams. Grade of steel, I assign to view. Again, beams, I will assign to beams parallel to X and Z, parallel to Z. Assign selected beams, yes. Parallel to Y, assign to selected beams, yes. To all my plates, XZ. Okay, assign. Yes. Then I'll save my project. Then let's run our analysis again. So let's go to Task Manager. So I will delete all the combination. They are the ones which are causing the problem. Then rerun my analysis. So again, let's so we can just run our analysis and do concrete design using RCDC. So we just end task manager. No. Then we'll end our task for Staadpro analysis. So we delete the design concrete. So right click, select, right click, then delete command. Yes. Let's add the combinations using BS, generate, add. Let's do run analysis. We will design concrete in RCDC. So I think we are going to use RCDC. So that was an error. Let's go to RCDC. So add project column. We are designing column first, then client. So just viewers, engineer Geoffrey. I'm going to use BS and select columns. Then create project. So this may take a bit long, but we have to be patient. Reading the analysis model. So my project has loaded. So you can see I've been able to import my project from Staadpro to RCDC. I will change steel grade to 500. But we can also use 550 because I'm considering earthquake in this project, which the cover will change to 35. Then 35 again. Go to setting, design settings. My columns are braced. Then OK. Reinforcement settings. Minimum I'll use T16. Maximum I'll use T20. Then OK. Basic load cases. Earthquake X, earthquake Y, Z, and then dead load, live load, wind load, Z. Then OK. Then add from analysis. Then OK. Regular we can use regular structure, but since we included combination of analysis, just include it. So we are going to check if column, the section size I used will pass. considering the fact that we included earthquake load, but in the original design they did not include earthquake considerations because also depend on the location, if the location is prone to earthquake. So let's go auto design. So there are several columns which are failing because maybe the cross section is too small, because as I was expecting the initial design there were no earthquake consideration, but here we can just increase the section. So PL is greater than maximum permissible, so we can increase the section. Then now this one is passing. So we are going to use 10 to 20, 5, 10. So we are going to increase the section to 300 by 400, then auto design. Okay. So you can see we have used class 30 of concrete, and the grade of steel is 550. So the original design, they did not take earthquake into consideration due to the location. So it also depends. It also depends on your locality and whether the place is prone to earthquake and such factors. So we can go to reports, we can generate our design calculations. In no time, you can select everything and then OK. So we can just print the calculations and save them. So I will save this project somewhere. Then print. Then go to report, go to detailed drawing, elevations. I normally would just generate the drawing. This is a good thing about RCDC. You can quickly generate the calculations and the detailing. Then you can organize your calculations and your drawings later, so that you don't have to do anything manually. But it's always good to learn to do things manually, and I have videos on how you can just manually quickly and easily detail your drawing, organize your calculations using Autocad, ArchiCAD, or if it's calculation, you can just use maybe Adobe PDF. So I'm generating the column elevation so that we can save them somewhere to use in our detailing later. you can see our um, so so you must save first, then you can save the drawing somewhere in form of DXF and just write a name. But you can see the column elevation is also generating not only the elevation but also the cross section. So that's why I normally just generate the elevation. So we can open our file in Autocad. As you can see, we have our details. So you can see there are some areas we have structural dowels because due to the fact that we did earthquake consideration. So earthquake is a bit critical. So if you are designing a locale where the place is not prone to earthquake, then you'll be a bit lucky. So next we will design beams and then slab. So I decided to do this video all in one, the complete building design in 3 hours. So I'll open RCDC again. So just put any name, then select beam. So you can just name it beams, then so I can select all the floors which are similar, then create the project. So you have got to be a bit patient here. Okay, this one has loaded a bit faster. Let's see if all right, now you can see we have imported our beam in RCDC. So let's just do the first floor, and then we can just use typical for the second and the roof floor, right? So I'm going just to use the first floor, then because I will just need to use I want to avoid torsion, so I will just need to include the flange, so to indicate my beam is flange. Then I want to use Euro code, then I'm going just for one floor, that the first floor, then I will use the same design for the second, third, and the roof floor. So it's I normally prefer to just do either one by one, or just do one floor then use the typical. Instead, just select all the floors, be making the project to take more time to load, and also having problem to indicate that your beams are flanged. So I just indicate that my DF is 150. That is the thickness of my slab. Then I'll copy and paste. So that would be one of the challenge, because I'll have to go adding the slab thickness one by one if I included all the floors. And here I will ignore torsion, value of less than 1.1. All my beams are flanged. I'll use class 25, 5 grade 550. Then my cover is 25. You can just try for 60. I will use a minimum of T16. So I can try a minimum spacing of 200. Then we are going to see if there be any necessity for SFL, that is side face reinforcement rebar, which I would like to avoid. Then we will use all the loads, earthquake EX, earthquake ZX, earthquake Z, dead load, live load. So I will just import these load, okay, all of them. I will use all these loads cases, all right, then just okay, and okay. From analysis, then okay. So if you do not include combination analysis, then you have to include, just use typical for regular structure. Then we're going to run our analysis, auto design. You can just either click that or just that run sign there. So I have the beam group are failing. Beam group 10. I will design group 10, and I will let me check where it is failing. So beam is failing in shear. So we just need to reduce the distance. Even if I increase the depth, it is still going to fail because it is failing in shear. It is failing in shear. That means I have to reduce the distance of links because I've used a link. My link is 200. I will need to reduce that. So I'll need to I'll go back to rebar. So I just reduce the minimum spacing to 100. I'll try 150. Let's see. So let's run our analysis again. If this failed, we're just going to lower the spacing, link spacing to minimum to 100 again. One major advantage with Staadpro RCDC is you can generate your detailing easily. So that is a very good advantage. It's still failing, so I will need to reduce the spacing to 100 again. And you can see the problem is if you select 150, it will just go for the lower value, just for all of them. Just go again to 150. It's still failing in shear. So let's just unlock the model and then just try 100. So no matter what you do here, it's failing in shear, just means the spacing, the minimum spacing need to be 100. Okay, it has passed now if you increase the depth. So that one is passing. So let's do the same. Let's try to increase the size, the cross section for the one which is failing. So beam 45, but you can also see it is missing the shear reinforcement, so we know which one is failing. Let's try 550. Let's try 600. If it's not working, we have to increase to lower the spacing, minimum spacing to 100. All right, so try to increase the grade of steel. So just we need to use minimum 100, but that can also be very expensive, especially if you have to use 100 for all your beams. So you have used many links. Also, considering that you have taken earthquake into consideration, so let's redo our analysis. I think we have changed that one to 100. So beam group 10 is still failing, so let's design again. Then we go to it's beam 29, but you can see clearly it's missing the shear reinforcement. So let's increase the size to 600. That was working, should work even now. Right, so then let's try now group 18. Then I just accept. Just group 18 is the one with now remaining. So let's try to increase the size. Let's try to increase the size of group beam 45. So actually we are 250. Let's see, increase the grade of concrete and the grade of steel. So I don't think we can edit side face reinforcement. I think we are designing the wrong beam, right? I think you should notice that the one which is missing shear reinforcement is beam 45. So let's increase beam 45, the cross section. So beam 45 is the one which is failing. Let us increase the size, the width. Can I try to increase the width? So now that one is as accept. So you should check which beam is missing reinforcement, whether shear or. So now all my beams have passed. So we can now go ahead and generate design calculations. We can check which beam size we change, so we can print this report so that when we go back we can change. And remember, this can also affect our column design and our footing design because the section of it. So we should go and edit and redo analysis before you redesign the column and the footing. But for an experienced engineer, I think there will be no much of change in load takedown, so I don't think it will much affect the design of column and footing. So you can change the river mark, use y we want to shear, change t, then okay. Yes, cross section, then okay. So it's generating the elevations. So this is my drawings. So you can save before we save again. So you can save in DXF form, choose desktop or any other folder, any new folder that you decide. Then choose the name which you can easily remember, so that you will compile all these to make the beam slab layout and the foundation layout, right? Where in the foundation layout is where you're going now to do your columns. So you can see now our longitude and our cross section. So remember, you will need also to edit to indicate that these beams are T and L section, just not rectangular. So there's a lot of editing to do here in our beam slab. Detail. So we can now do our footing. And remember, we have staircase. We did not include staircase load, and staircase load is normally about 22 kilonewtons, so we should include staircase load at this point because we did not model our staircase. But remember, we already used a bigger cross section of 400 by 200, so that one could save the day instead of just having to redo all that work. You know that your column are safe. And also the beam, the span is not that big, so I think 450 by 200 should be okay, because the span is not that long, so it can hold that staircase landing, and also landing 1 and landing 2 without no issue, so that should be no problem. And also a column, we use 400 by 200, actually 225, so that cross section is already bigger than the rest in the structure, and so it will pass. So let's go and design our slab in RCDC. So remember, our staircase is double flight stair, so it means it's is double, so not single flight. So we're going to design a slab. Just use any name, and just use BS. In beams, I'm very comfortable using Eurocode because BS code, there's one issue called crack wind, so don't want to deal with that. So I will add impulse load. So self weight of slab is usually the depth multiplied by unit weight of concrete. So about 3.75. But I think in RCDC it's automatic, but you can just include it. So it'll be about 5 imposed, then live load 4. Slab thickness on 50, so we can just copy and paste. We are going to use classify for 60. Method of 20 is okay. So then okay. I'm going to use spacing of 200. So auto design. I would prefer T10, so I'll go just to setting and change my preferred rebar size to T10. So then okay. Remember, when you're designing manually, you just go for the most critical panel, that is the largest slab in terms of length and width. Then you just use the same design for the rest of the section. So you can see T10 300 is passing. It's so good to compare RCDC with Excel. So I can just maybe use I can just, if I want a spacing of maximum of 200, just change, then redo analysis, design, auto design. Then we can go to the reports, generate design calculations. Then you can get the design stairs. So this one is a single flight. So, but my stairs is not single flight, so my stairs is not single flight, so I will get this my detailing. My staircase section is cut out, so you can just select through and then auto design again. Then in plan detailing, so if RCDC, you can see you can quickly just use these detailings and edit your drawing instead of just doing manually. Just save the project and then save this bottom reinforcement. This is just for the bottom, then you can save for the top reinforcement. Save it somewhere, the name you can remember, then save. This is in form of DXF. So now finally we're going to design our footing. So we can add our staircase load for the sake of our footing, because our footing is going to carry more load. Although our column is okay in terms of design, we have to take into consideration that we have an extra load for the staircase. So because that will much affect our footing, but if we exclude it, it will reflect in our footing. So we'll add negative 22 kilonewton per meter in the global Y, and then add, we just do our analysis for our landing, close, then so in terms of earthquake, just do the same thing. Select, holding control in my keyboard, select all the places in my landing, then I will select my landing 2, select view selected only, then select my landing 2. And remember, landing 1 and 2 are not supposed to be at the same level, but no problem, because the only thing we take into consideration here is to design our, then when we are detailing, it will be different. Then we are going to design our footing. So reading analysis model, we have already imported quickly our footing to RCDC. Now this is column, so this is footing. Go setting, general settings, check, another check overburden. We can change our net bearing capacity, so 200 is okay. So I will change my water table foundation depth. So sorry for that, sorry for that interruption. Then okay. Then okay. Reinforcement, we change the reinforcement 12, 16. Change here to, then okay. Then let's go to our analysis. We'll include all load cases. Z, dead load, live load, wind load. Then select all of them, include. Then let's do our analysis. So we apply for a combination from the analysis. So we use for regular structure. So that is for serviceability, just one. So sizing factor is just for, we use serviceability limit state, that is a factor of 1. So let's do our analysis. So the footings, designing footing. So all my footing have passed. You can see the effect of, I think this is because of earthquake. That's why some of my footings are very big. But when you are designing manually, I think for earthquake you just use some percentage of the dead load, about maybe 3% of the dead load. for you add for earthquake when you are using Excel. So you can generate this drawing, the plan and the section, then okay. Then you can save this somewhere. So in another video I will show you how to group these bases to avoid all these type of bases, because there are so many which you can't do in real life, having so many type of bases. This is more than 10. If you like my video, please consider to subscribe to my YouTube channel. Thank you.